Good day, everyone. Welcome to the Certified Math Majors channel. Now, in this video, I am going to teach you a trick for finding the derivative of a reciprocal function. Now, the formula that we're going to use in order to find the derivative of a reciprocal function in a short way will be equal to negative f prime of x all over f of x squared. So as you can see, you have a squared term in the denominator. So this is just actually taken from the quotient rule. So if we're going to get the derivative of any reciprocal function and apply the quotient rule, you will notice that this form will come out. So what we're doing here is just we basically skip the long process of doing the derivative of a reciprocal using the quotient rule and go immediately to this one. But again, it's very important that you check it, or you can derive the formula yourself using the quotient rule. And for a more detailed and comprehensive explanation of the quotient rule, you can subscribe to a Gina's mathematics class, and you can search the video for the derivative of a quotient. And you can see there a very exquisite explanation on how the derivative of a quotient is being done. But this time, let's do the short trick for the reciprocal functions. Let's have the first example. You have number one, y is equals to 1 all over 3x. So again, the formula is just equals to negative f prime of x all over f of x squared. So that means you just get the reciprocal or the derivative of the function. The function is 3x. Derivative is 3. And then, of course, you have the negative. So this will be negative 3 over the function is 3x. So that will be 3x squared. We simplify this one. This is negative 3 over 9x squared. We can actually cancel this one out. So this becomes negative 1 over 3x squared. And this is our derivative. Next, number 2, you have y is equals to 4 over x squared plus 5. Now, this seems to be not a reciprocal, but again, we can take out the 4 because constants in derivatives do not matter. It does not affect the answer. So we take out the 4, and then you have 1 over x squared plus 5. So now, you have a reciprocal function. We can now get the derivative that is equals to 4 times the negative of the function, or the negative of the derivative of the function. That's negative. Derivative of x squared minus 5 is just actually 2x all over the function x squared plus 5 squared. And then we can simplify this one further. This is now equal to 4 times negative 2x is equals to negative 8 all over x squared plus 5 squared. And this is your answer. Next, third one. You have y is equals to negative 3 over ln x. The same thing, we take out the constant, that's negative 3, then 1 over ln x. So y prime is equals to negative 3 over negative of the derivative of the function. So derivative of ln x is 1 over x over the square of the function ln x squared. So we can simplify this. This becomes 3 times negative 3 times negative 1 over x. This becomes positive 3 over x over ln squared x. You simplify this further, then our answer will be equal to 3 over 3 ln squared x, and this is now our answer for the derivative of this function. Next, lastly, we have y is equals to 1 over ln of x squared minus 3. So y is equals to the negative of the derivative of the function. Now the function consists of ln. Now in my last video, I already discussed a trick on how to find the derivatives of logarithmic functions or of natural logarithmic functions in an easier way, and that is the derivative of the function. So derivative of the function is 2x all over the argument. So that is the derivative of the function now using the shortcut trick that we had, all over the function, which is x squared minus 3 squared. Now, you can do some algebraic methods to simplify this one, but the final answer to this is equals to 2x all over. You have x squared minus 3 times the ln squared of x squared minus 3. And that is now your final answer for the derivative of this one. That's all for this video. Please subscribe to our channel to get more mathematical tricks. Thank you so much and enjoy learning.